Okay, so now we are going to the week 4 lecture, and we're continuing in the vein of epistemology, um, but we're moving to talk about one particular argument from David Hume. So, well, we will look at one argument from David Hume in the lecture, the recorded lecture, and then you will continue to look at the work of David Hume in your reading group stuff. So that's what we're covering this week. They're both epistemological. In your reading group, in the reading sequence, you'll be looking at David Hume's arguments about the problem of inductive reasoning, and I'll talk about induction here in the lecture a little bit. And there are actually two different arguments, that you'll be looking at. They're in one chapter. They're sort of it's sort of one chapter with two parts or something like that. So this will be a little bit different than the previous weeks where you've had only like one argument to deal with. You sort of had two arguments to deal with the Kuhn thing, but this will be a little bit, the arguments will be a little bit more distinct in this case. But they're both about Hume and the problem of induction. So that's what you'll be discussing as you go along. So David Hume, who's that? Well, first, let's talk about the segue. So, as I've already said, we're still discussing epistemology. Last week, we talked about skepticism, mostly radical skepticism, and in your reading groups, external world skepticism, which are both pretty radical in that they call into question a huge chunk of our beliefs. Radical skepticism calls into question all of our beliefs at once, and the fact that, worries whether or not we can have any well-justified beliefs at all. External world skepticism still calls into question a whole bunch of our beliefs, given that so many of our beliefs are about, objects in the world, whether or not there are cups and things of that nature. But it doesn't necessarily call into question absolutely everything, but pretty close. So Sextus Empiricus, when we were looking at his regress argument, says that every belief stands unjustified. So that's how we get the radical skeptical conclusion. We say that there is not a single belief that we have which is justified because, as he said, each mode of justification, or each way that we might justify a belief, attempt to, ends up doing something bad. It ends up being circular. It ends up going on forever. Or it ends up invoking beliefs which are themselves unjustified and we don't even try to justify them. So inductive reasoning doesn't escape this criticism. Inductive reasoning is itself a form of reasoning which attempts to justify beliefs by appealing to evidence. And what it's going to turn out, as you'll see when you look at Hume, is that the problem of induction is that it ends up being circular, right? So that is, of course, one of the ways of attempted justification that Empiricus says is no good, so induction is no good. And given that induction is the basis of pretty much every scientific claim, that means scientific claims are unjustified, on this way of thinking. So that looks pretty bad, right? In particular, the thing that makes them circular is that they depend on a belief, on an observation that the past and the future resemble each other. That is, the way things work in the past is the way that they're going to work in the future. But on what basis is that belief justified? Well, it itself is an observation. Why do we think that the past and the future will resemble each other? Well, because they have done it for so long. We have frequently observed the past to resemble the future. But of course, that's induction. So you're trying to use induction to justify the use of induction, which is, of course, circular. And so that's the general gist of what you're going to see in the problem of induction arguments that you do for your reading sequence. So if you're not exactly sure yet what induction is, here's an example. I'll just read this out. On the previous 1 billion occasions that a sample of water, deionized water, has been raised to 100 degrees Celsius at 1 atmosphere of pressure, it has boiled. So this is that set of observations, the past, basically. And we're looking for a pattern in those observations. What pattern do we find? Well, we find a pattern of water being raised to this particular temperature, causing it to begin a state change, right? So when I say begin a state change, it starts boiling and the water starts to turn to steam, right, from liquid to gas. So this is what happens at 100 degrees Celsius at 1 atmosphere of pressure to water which is deionized. So given that we have observed this pattern across a billion instances in the past, we take it that water heating to 100 degrees Celsius always co-occurs, always happens at the same time with water boiling, right? So these two things always happen at the same time. Given that they have, on the first billion occasions, happened at the same time, or one has followed right after the other, we think that on the 1 billionth time that we heat a sample of deionized water to 100 degrees Celsius at 1 atmosphere of pressure, it will boil. So now we're making a prediction. We're saying this pattern from the past is going to persist into the future. So this is the conclusion of an inductive argument. It's a prediction that an event and a certain set of conditions will continue to co-occur. So that's all I mean when I say that the past and the future resemble each other. So inductive arguments, even if we say that there's no significant problem with them, right? Even if we accept that they work and that we can have justified beliefs on the basis of them, we have to note that they are distinct from deductive arguments, and that the certainty which attends these conclusions is not as much as the certainty which attends the conclusions of deductive arguments. What I mean when I say that is that an inductive argument is, at best, 99.9999999% certain. This goes together with what we looked at in Popper's demarcation argument. He says, look, a scientific claim, an inductive claim, those two things aren't synonymous. You can have probably scientific claims which aren't inductive, but let's just identify them for the purposes of this discussion. So a scientific claim must be such that it could be proven false, right? Well, that sort of just means that it's not 100% certain. That tomorrow we could observe something that makes us believe that it's been falsified. And that's kind of what's going on here with induction, right? The projection of past patterns into the future doesn't guarantee, right? The fact that I have, every time before I've raised water to 100 degrees Celsius, the fact that that has always led to that water boiling doesn't tell me for certain that tomorrow, when I raise some water to 100 degrees Celsius, that it will boil. The fact that the sun has risen for the past, every day for the past 4 billion years doesn't tell you that it's going to rise tomorrow, because conditions might change, right? The Earth might get hit by a comet and go careening off into space, in which case, the sun's never going to rise again. The sun might explode. There's all kinds of things that might happen. We have no guarantee that the laws of nature are going to stay the way they are. We have no guarantee that the conditions under which we have been making observations for the first billion times are going to stay the same on the 1,000,001st time. So that's the difference, and that sort of that makes sense, hopefully, a little bit of why a scientific claim, because it's an inductive claim, has to admit that it could be proven false. So inductive claims that try and project a pattern of observation into the future, they don't count as, we don't label them as valid or sound. Only deductive arguments count as valid or sound. Inductive arguments are just more or less confirmed, right? They have more observations in their favor, right? So if we only had one observation in the past of water boiling at 100 degrees Celsius, the inductive argument that it's going to do it on the second time is pretty weak, right? Just because it happened once doesn't mean that it's going to happen the next time. And you can see again how this sort of feeds into the way I described the no miracles argument in the week recap. You know, every time you add another success of prediction, that gives you a little bit more certainty. It makes it a little bit more likely that you can confidently predict the same thing is going to happen in the future. That is, it makes you more confident that the pattern that you've identified is a real pattern and not a fluke. Okay? So hopefully this idea of induction is sort of, this way of describing it is now sort of crystallizing your understanding of the arguments from week 2. All right, so that's induction. Now let's talk a bit about David Hume. So as I said, he is the philosopher whose arguments we're going to be looking at this week. Incidentally, since there's only one argument in this set of slides, I'm not going to break up the video. Consequently, this video is going to be a bit longer because the argument's a bit long. So I might break it up if it starts to be really long, but my intention at this moment is to have simply one video for the week. So David Hume was an 18th century Scottish philosopher, and he is among the most well-known philosophers in the history of at least Western analytic philosophy. So he is known for being an empiricist, which means putting forward theories about knowledge which depend on observations, on seeing how the world works and finding patterns, rather than on sort of abstract reasoning about sort of unobservable principles. He's also known for being generally skeptical. So he puts forward skeptical hypothesis about the existence of God, about the effectiveness of induction, about sort of moral philosophy, so on and so forth. He is most well known probably for developing the so-called problem of induction. Right now, he wasn't the first person to realize that there's a problem with this inductive form of reasoning, with this form of reasoning where we project past patterns into the future. This problem was well established or well known by many different groups of thinkers long beforehand. We already saw a form of it with the work of Sextus Empiricus. Sextus Empiricus was himself reporting the work of earlier Greek philosophers, and there is a well-known Indian school of philosophy, and by that I mean the subcontinent of India, the country, which was several hundred years before, probably even 1,000 years before Hume, probably roughly contemporary with the time that it's thought of in Greece, which reports this problem with inductive reasoning. So it's a well-understood difficulty which David Hume is credited with giving the clearest formulation of. We're not looking at that right now. We're looking at his argument against miracles. So in particular, this is still an epistemological argument. It's an argument against believing in miracles. It's not an argument against the possibility that there are miracles. There's a lot of, as the chapter in the textbook will indicate to you, there's a lot of questions about how to best interpret this argument. What exactly was Hume trying to argue? And then, of course, depending on what we interpret him as trying to argue, we can assign different amounts of success. So if his argument is making a stronger claim, it's likely that it's less successful. If it's making a weaker claim, then it's more successful. We won't worry too much about the rival interpretations. We're going to go just with the way that it's been rendered for us in the textbook and look at that. So these are very long premises, and there's a whole bunch of them. I'll go through them, just reading them out as I usually do, and then we'll have to explain a lot of the terminology in it. Premise 1, that A is the case provides evidence E for B's being the case if and only if the number of times in which we have observed A and then have observed B is greater than the number of times in which we have observed that A was not followed by B. So I'm going to explain these as we go because they're long and a bit complicated. This is just saying that observations used as evidence, as the basis for a prediction that something else is going to happen, they only provide evidence when that thing which we count as evidence, more often than not, has been observed to co-occur with the claim that we're trying to make. So we can go back to the water boiling example. That water being at 100 degrees is evidence for the claim that the water is going to boil. That piece of evidence that it's 100 degrees only counts in favor of the thesis that water is going to boil if, more often than not, we have observed water to boil when it has gotten to 100 degrees Celsius. To give you sort of another example, let's say it only counts as good evidence that your dog has, chewed something in the house, right? So suppose your dog is right at the door when you come home. This only counts as evidence that they've chewed something up in the house if usually, more often than not, when they are at the door greeting you when you come home, it's because they've done something bad, right? So again, you have to have this collection of cases in which dog being at the door is observed right before some destruction the dog has wrought in your house. The more often those two things are observed together, the stronger the dog being at the door counts as evidence in favor of the dog has done something naughty, right? Hopefully those examples clarify what's going on. If the dog being at the door is not more often connected with the dog having done something naughty, then you can't count the fact that the dog is right now at the door being an indicator that they've done something bad. Premise 2. The strength of E is proportional to the ratio among the number of times which we have observed A and then have observed B, and the number of times in which we have observed A that was not followed by B. So I've already basically explained this. Something only counts as evidence for the dog being at the door only counts as evidence that the dog has done something bad if, more often than not, the dog being at the door has been observed with the dog having done something bad, right? Further, the second claim says it is stronger evidence the higher that ratio is. So if it's a 9 times out of 10 that when the dog has been at the door, it means they've done something bad. That's stronger evidence that on this occasion, the dog being at the door means they've done something bad, than if you've only had 7 out of 10, right? So if only 7 out of 10 times before the dog being at the door has indicated that the dog has done something bad, that means it's weaker evidence, right? And at some point, it just stops being evidence at all. Premise 3 is another long one. The existence of testimony of type K, henceforth take K testimony, to the effect that B was not the case, provides evidence, et, for the proposition that B was not the case, only if the number of times in which we have received K testimony for a proposition and then observed that that proposition is true is greater than the number of times in which we have received K testimony for a proposition and then have observed that that proposition is not true. Again, that sounds really long and complicated. You may have no clue what it means. This is not saying anything different from P1 and 2. Why do we have this premise then? Well, because it's shifting from a general idea about when some particular thing counts as evidence for something else to specifically talking about testimony, right? So now we're not talking about the dog being at the door being evidence that the dog has done something bad. Now we're saying someone telling you that something has happened counts as evidence that that thing has actually happened, right? So think of the boy who cried wolf scenario here. So the existence of some testimony of type K, right, to the effect that B was not the case. So let's say boy cries wolf, and then every time previously boy has cried wolf, there have been no wolves. that shows that this testimony is not good evidence that there are wolves, right? If, on the other hand, every time before that the boy has cried wolf, that has indicated that there is a wolf, then that boy's testimony that there's a wolf is good evidence that there is a wolf. This doesn't just refer to a single person. This refers to people in general, right? So imagine that instead of the boy who cried wolf, we have to think of like the society cried wolf or something like that. If every time that someone says it's raining outside, it's actually sunny outside, then whenever any particular person tells you it's raining outside, you don't have good evidence to believe that it's raining outside, right? Because people tend to lie about that, it seems, in this strange society. So that's all that's going on here, is that what we talked about in 1 and 2 is being converted to being specifically about testimony, right? So testimony is a type of evidence that we usually accept. When you ask someone about the weather, you are taking it that their testimony, them just telling you that it's raining outside or that it's sunny outside, is good enough evidence for you to believe it. And we're all familiar with the idea that, there are some people we don't ask about certain things because we don't trust them to be able to know, right? So that's just what's being gotten at here. All right, more long premises. Premise 4. The strength of ET is proportional to the ratio among the number of times in which we have received K testimony for a proposition and then have observed that the proposition was true, and the number of times in which we have received K testimony for a proposition and then have observed that the proposition was not true. Again, nothing really new is being said here. So just like premise 1 and 2 are just telling us about how observational evidence works, premise 3 is converting this general point. Premise 3 is actually just is a conversion of premise 1 to talking about testimony. Premise 4 here is just a conversion of premise 2 to talking specifically about testimony. And if you read them very closely, you can see that. Then have observed that the proposition was true, right? The ratio among the number of times. The ratio among the number of times, right? So when you're looking at these arguments which have really long, complicated seeming premises, you have to get past the fact that they are kind of intimidating, right? You have to look for the sort of patterns in the phrasing. So as I said in the first week, as I've said a couple of times since then, deductive arguments like this are phrased in an incredibly repetitive fashion in order to help you see the thread going through the entire argument, right? So the number of times in which we have observed A and then have observed B. The number of times in which we have received K testimony, which is essentially the same as observing A, and then observed that the proposition was true, observed B, right? So you have to kind of don't focus on the exact words and look for the patterns of wording in order to see the connection between these premises. So to repeat, premise 1 and premise 3 are fundamentally the same. 3 is just a more specific version of 1, more specific in that it's talking about testimony as evidence. Premise 4 is just a more specific version of premise 2, in that it's talking about the proportion amongst the number of times that someone has told us something and then we have observed it to be true, right? So again, going back to the boy who cried wolf, if the number of times in which boy has said there's a wolf and then we have gone out and observed that there isn't a wolf, if more times than not we have observed no wolf after he says there's a wolf, then we take it that him saying wolf doesn't give us any good reason to believe that there's a wolf. If, on the other hand, every time he says wolf, or most of the times that he says wolf, we have gone out and observed and there has been a wolf, then we will take his testimony, wolf, to be a good indication that there is one. Again, this is very repetitive, but hopefully you're not kind of getting confused by the repetitiveness. Premise 5. Whenever one's global evidence is constituted by E1 and E2, and E1 is evidence in favor of a given P, that just means a proposition, and evidence E2, E2 is evidence for P, it is rational to believe that P only if E1 is stronger than E2. It is rational to disbelieve E1 only if E2 is stronger than E1. And it is rational to withhold belief as to whether P and if the strength of E1 and E2 are the same. Again, that sounds very complicated, but it's not. You already all operate by this premise most of the time anyway. All it's telling you is that if you have two sets of evidence, right, and you're trying to decide on the basis of this evidence whether to believe that it's raining outside or whether to believe that it's not raining outside, you should only believe that it's raining outside if your evidence for that is better than your evidence for the fact that it's not raining outside. And if your evidence for it's raining outside versus it's not raining outside is equally good, then you should say, well, I can't make a decision, right? That's what withhold belief means. So once again, this is phrased in a very complicated way, but it's very straightforward. It's a very straightforward principle. It's something that we all believe all the time, right? We think that you should believe what you have the best evidence for. This is just giving a very formal statement of that very basic principle. All right, so these are a bit shorter. Premise 6. There is K testimony to the occurrence of a miracle, M. So now we're getting down to sort of the specific stuff about miracles. So P6 just means someone told you that there's a miracle, right? Someone said, hey, I witnessed a miracle. Some water turned into wine. Somebody, jumped over a tall building in a single bound, something like that, right? P7, there is a law of nature saying that every A is followed by B. And the K testimony is to the effect that A was not followed by B. So this is Hume kind of giving us a definition of a miracle. So our definition of a miracle that we kind of got from the Putnam argument was very vague. It was just saying that a miracle is a streak of incredible luck or some kind of supernatural interference. Here we have the idea that miracles are essentially violations of a law of nature, right? So a law of nature says something like, if you bring a sample of deionized water to 100 degrees Celsius at 1 atmosphere of pressure, it will boil. That kind of thing is a law of nature, right? The boiling points and melting points of particular elements, the law of gravity, the laws of motion, those are taken to be things which do not admit of exceptions, right? So the idea is that a miracle, and then of course testimony for a miracle, is telling you, hey, you know that law of nature? I saw something not follow it, right? So someone would say something like, oh man, I had my keys, I had them in my hand, I dropped them, and they didn't do what they're always supposed to do, namely fall to the ground. Okay? That would be sort of testimony of a miracle. That's a very strange thing to call a miracle, but that's what Hume's definition is. It doesn't have to have this religious connotation. It is simply a violation of a law of nature. Okay. So premise 8 here is a premise for a reductio ad absurdum argument. What does that mean? Well, that means Hume is saying in premise 8 what he's eventually going to prove to be false. He says, oh, it's rational to accept that this miracle occurred, right? So he doesn't believe that, and ultimately that's what he's going to sort of say is false in his conclusion. But the way the reductio argument works is that you say, oh, this thing that isn't actually true, let's assume that it's true and see what kind of garbage it gets us into. We've seen this already when we did Anselm's argument. He says, well, imagine that there is something greater than the greatest thing that you can imagine, right? Suppose that's possible. Well, if you suppose that's possible, we get into some trouble. So that's not actually possible. So that's what's going on in premise 8. Premise 9. That A was the case provides evidence E star for the proposition that B was the case, which is weaker than the evidence ET provided by the K testimony for the proposition that B was not the case. So again, now we're back into the really complicated premises, and you can see them. You can see it here again in T. What's going on between premises 9 and basically 9 and 10 is he's saying what it would be like if it were rational to accept that M occurred, right? To accept that a miracle has occurred. So he's saying that the evidence for B being the case is weaker than the evidence for B not being the case. Oops. Nope, I moved over into another class's arguments slide accidentally there. Okay, premise 10. If it is rational to accept that M occurred, then that A was the case provides evidence E star for the proposition that B was the case, which is weaker than the evidence ET provided by K testimony for the proposition that B was not the case. Again, we are going into more specific versions of this proposition 3 and 4 now. And also, we're invoking a little bit of premise 5. So what's going on here is he's saying, well, look, if it's rational to accept M, then that means that we have better evidence that A did not follow B than we have evidence that A did follow B. And this is going back to this definition of a law of nature and the definition to a miracle. If someone tells you that you've seen a miracle, then we say that it's rational to believe that, then we have to be saying that their testimony that a miracle happened is stronger evidence that the miracle did happen than the law of nature counts as being evidence against the fact that the miracle happened. Proposition 11, L, that is the law of nature, has been established by a firm and unalterable experience of many instances of A's that were followed by instances of B without exception. Premise 12, that A was the case provides the strongest possible evidence E star for the proposition that B was the case. 13, ET is stronger than the strongest possible evidence E star. It is not the case that ET is stronger than E star. It is not rational to accept that M occurred. So let me go through that again with a more concrete example. So we have our trivial miracle again. Someone says, hey, guess what? I dropped my keys and they just floated there, right? They didn't fall to the ground. So someone tells you that. That's a piece of evidence that a miracle occurred. You have to compare that to basically the law of gravity. The law of gravity is composed of all the hundreds, millions, billions of observations made, well, actually, we're confining ourselves to our own observations. So let's not say that we've made a billion of observations. Let's say that you've dropped things 100 million times, and every time that has fallen to the ground, right? You've dropped them, it's fallen to the ground. So now you have 100 million instances saying that when you drop things, they fall to the ground. And one instance which says, oh, I dropped something and it didn't fall to the ground. In order for the testimony of a miracle to actually make it rational to believe, you would have to say that the one instance is better evidence than the 100 million instances. But that's obviously not the case. That's what Hume is saying here. He's saying that the single testimony, even a handful of testimonies from various people to the effect that some law of nature was violated, doesn't really outweigh the number of observations which are sort of encoded in the law of nature. So a law of nature is nothing but hundreds, thousands, millions of observations that when you drop something, it falls to the ground, right? So having even 100 compared to 100 million, that means that the evidence that it didn't fall to the ground is weaker than the evidence that it did. So it's actually not rational to believe in the miracle. And that's what C2 is telling us. It's not rational to accept that some miracle occurred simply on the basis of these scattered testimonies. Now, this does give us a criterion for when it would be permissible to believe in sort of that a miracle had actually happened. You'd have to have enough instances of testimony that a miracle happened to outweigh all of the observations encoded in that law of nature. So, however many observations that is, right, compared to your everyday, dropping things and then falling, how many times would some people have to tell you that they dropped something and that it didn't fall for you to believe that, a miracle had occurred? That's what you have to think. And Hume's point is, it's so many that it's basically impossible. So hopefully I've done a good job of kind of cutting through the wordiness of these premises and their kind of technical nature to give you an idea of what's actually going on here. It's not particularly complicated. It's just boiling down to, do you have more observations in favor of the miracle than you have against the miracle? And Hume says, given what a miracle is, that's basically not possible. Okay, so as I said, here's the short version of it. If someone told you that they saw 1 Celsius practically ice-cold water boil, you'd say, no, you didn't. You wouldn't go, wow, that's amazing. You would just think that they were mistaken. And you would think this because you have a firm and unalterable experience, so this is going back to premise 11 here, that when water is that cold, it just doesn't boil. That's just not how things work. You have this firm and unalterable experience of only sufficiently hot water boiling, right? So water being sufficiently heated is A, and then water boiling is B. You always see A and B together. You almost never, or basically never, see A and then don't see B, or see B and not A. That's what Hume is talking about when he's saying this firm and unalterable experience of the co-occurrence of these things. That means every time you see one, you see the other. That's what a law of nature is, according to Hume. So that's the very short version of his argument. So, now a little bit into these interpretation matters. As I mentioned earlier, Hume is at the very least saying that we shouldn't believe miracles, you shouldn't have believed that a miracle has occurred on the basis of some person's testimony that one has occurred. Once again, even a handful of testimonies, even a whole bunch of testimonies don't outweigh the number of observations which are encoded in that law of nature and that firm and unalterable experience of your everyday life. Okay, again, if someone told you that they dropped their keys or let go of their keys and they just floated in the air, if someone told you that they saw almost freezing water boil, you'd go, nah. Because your firm and unalterable experience of your everyday life says that that's just not how things work. Now, that's the least that he's saying. He might also be saying that even when you make a single observation of something anomalous, something weird happening, you shouldn't believe that it's a miracle. So the fact that it's testimony and the fact that it's your own observation make only a little bit of difference. So if you have but one observation of sort of letting go of something and just floating there versus hundreds and millions of observations of letting something go and it dropping, your first belief shouldn't be, it's a miracle, right? Going back to the structure of induction, your first belief should be that the conditions have changed, right? Something weird is going on, but it's not a violation of a law of nature. It's not some sort of, intercession of an outside force. So this is a very controversial argument, in part because people can't really agree on what Hume wanted to say, and given that they can't agree on what he wanted to say, they can't agree on how successful he was. Those two things are interlinked. In order to properly critique an argument, you have to actually know what it's saying. And so this is why interpretation is so important. This is why it is so important to be clear. So we've seen these very long and repetitive arguments, which you would never talk this way in normal conversation. Well, that's because normal conversation is riddled with misunderstandings. What philosophers, especially analytic philosophers, are trying to do is put forward their arguments in a way such that no one could misunderstand them, so that everyone has the same idea of what argument is being criticized. This is why a good philosophical argument, a good philosophical paper, really a good scholarly paper, a good scholarly argument, you have to tell people up front what you're talking about. You have to define your terms. You have to say, when I say miracle, I mean violation of a law of nature. When I say law of nature, I mean a firm and unalterable experience of two things being observed together. What you may see if you go back to your grades for the week 2 quiz is that Putnam's definition of miracle and what you took a miracle to be kind of mismatched a little bit. Some of you said, but the success of science is miraculous. Look at all this really cool stuff we can do. Isn't that miraculous? Well, in a sense, there's one meaning of the word miraculous in which that's true. The meaning in which something is miraculous when it's revolutionary and surprising, right? When it sort of strains the imagination that human beings could do this, right? Miraculous there just means amazing. But that's not what Putnam meant. Putnam means miraculous in the sense of up to the intervention of some outside force or some huge streak of luck. But he didn't really say that. I had to provide that idea a little bit and then kind of explain it to you. Hume, in his argument, tells us exactly what he means by miracle. He doesn't mean really cool, amazing thing. He means violation of the law of nature. And then he tells you what a law of nature is so that you know what a violation of it looks like. But even though Hume has been this clear, there is still some difficulty in interpreting, right? So there's this idea of whether Hume is saying that we shouldn't believe in miracles at all, whether we shouldn't believe in miracles on the basis of other people's testimony. Should we even believe that unusual things happen, right? Some people have criticized Hume's argument because it makes it look like that we can't believe that weird stuff happens. We have to believe that everything is perfectly regular all the time. If that were the upshot of Hume's argument, then it's obviously a bad argument because weird stuff does happen. And it's important here that Hume's idea of law of nature is based on observations, right? Hume doesn't think that laws of nature are these abstract principles that we discover by reasoning. He believes they are just incredibly regular patterns of observation, right? Given that he believes that, if his argument is interpreted in a particular way, then we can't believe anything weird happens. We can't believe anything unusual ever happens, and that's clearly a conclusion that's no good. And I say that right here, it would make our belief system unacceptably rigid because unusual things do happen. So one thing that we can do to talk about, to make sense of weird things happening, is we have to say that when we witness something weird happen, it's not violating a law of nature. It's just that we haven't articulated our observations well enough. We haven't accounted for a particular change of condition, right? So I have been bizarrely specific when I've talked about water boiling, right? I've said a sample of deionized water at 1 atmosphere of pressure heated to 100 degrees Celsius. That's not how we usually talk about boiling. We just say, oh, water boils at 212 degrees Fahrenheit or 100 degrees Celsius. We don't make this, big to-do about it being deionized or about, the atmospheres of pressure, because usually that's not pertinent. But in order to sort of give a little bit more wiggle room to Hume's argument, we do need to be specific about these. So, as a matter of fact, in Johnson City, water doesn't boil at 100 degrees Celsius. It boils at a lower temperature than that. So if you went and measured the temperature of your boiling water and saw that it was below 100 degrees Celsius, would you go, it's a miracle? No, because remember, the law of nature is actually 100 degrees Celsius at 1 atmosphere of pressure. We are not at 1 atmosphere of pressure. 1 atmosphere of pressure is at sea level, right? That's the baseline. It's something like every 500 feet, the boiling point of water goes down by like half a degree, something to that effect. So because Johnson City's average elevation is 1,650 feet above sea level, the boiling temperature of water is lowered. Anyone who's ever lived, say, in the Rocky Mountains, in any high mountainous area, you know that it's harder to cook, especially, with water, because you have to get things heated in order to cook things through. And so if the water appears to be boiling, but the temperature is lower, things won't cook all the way through. It'll take your spaghetti longer to boil. It'll take your spaghetti longer to cook, even though the water is boiling, right? So a boiling pot of spaghetti, in Orlando, Florida, cooks faster than a boiling pot of spaghetti in Denver, Colorado, because of the elevation difference. Likewise, when you put things into water, it can change the boiling temperature. So for instance, salt. When you put salt in water, it raises the boiling point. So it will take the water longer to boil, but that boiling water will be hotter. And so it will cook things faster. So a salted pot of boiling spaghetti cooks faster than an unsalted pot of boiling spaghetti once they get to the boiling point, because the boiling water in the salty pot is hotter than the boiling water in the not salty pot. So once again, if I was trying to boil salt water here in Johnson City, and it didn't boil until, 220 degrees, we wouldn't say, it's a miracle. We'd say, oh, well, the law of nature is specifically about deionized water that doesn't have any salt ions in it at 1 atmosphere of pressure. So salt water at a high place above sea level, there's 2 parts of the real law of nature that have sort of gone out the window. Now, this kind of helps a little bit. It helps us, account for some of the weird things that happen. It's just that we don't specify clearly enough what the actual law of nature is, but that doesn't help as in a general way to resolve the problem that I pointed out here. But this is the kind of thing that you have to think about, or that people do think about when they are interpreting Hume's argument and evaluating the claims. Okay, so that was quite long and complicated in places. Hopefully, by sort of cutting through the technical jargon and giving you concrete examples, I have made it a bit clearer. If not, please do feel free to email me with some questions before you go into doing any of the quizzes and stuff like that. I'm not going to ask you about the incredibly specific premises, the incredibly technical premises in the quizzes, but you need to understand the general thing of what's going on in Hume's arguments. So if you're unclear at all, please do email me as soon as you think of the questions so that I can help you out. Now, for your group work this week, you're still looking at Hume, and you're going to look at Hume's discussion of the problem of induction, which I've already given you a little bit of a primer about at the very beginning of this lecture. So as usual, this chapter 45, the arguments in there, that's what you do your active reading assignment on, that's what you do your group discussion on, and that's what you do your individual summary. Also, don't forget that, you will already have turned in by the time you see the thesis assignment. Don't forget to be looking out for your feedback to those, because you'll take the feedback from those, and that will help you in about 2 weeks' time when I assign the next part of that presentation sequence.